after, okay? How many minutes into the video were you until it's page 4? 15 minutes in? 20 minutes in? Something like that? It's not the whole video, right? So there we go. A couple of just reminding you of the angles: acute, obtuse, right, straight, reflex is greater than 180. We're going to have a lot of straight angles. So that one is important to know what that is. It's just 180 from end to end, okay? You're also going to have to be comfortable with complementary. I don't know if I made the cheesy remark, it's right to compliment someone. Right is the word that's supposed to remind you of a 90-degree angle. So if you have a 90 and you're cutting that up into several smaller angles, if they all add up to 90, we call them complementary altogether. Most of the time it's 2 angles, but it could be more than 2. Then you have your supplementary, which I call the hat. Okay, a straight angle is always equal to 180. This is the shortcut I use quite often to justify. We're going to do a lot of justifying. So if you, I don't know if I use this exact same one for your notes, so your notes might be the video might be a little different than this, but this is the shortcut here for that. I use that a lot. And so again, if you can ever draw a straight line anywhere, okay, if you're able to see that. So I'm going to add an example here. For example, let's say this one is a little bit on a slant, but it's still a straight line. If you see something going off of it like this, and you know that this is 40, you should realize, oh, there's a straight line here. If you're not sure what a straight line looks like, a ruler helps, okay? Is that a straight line? Yes. So if this is 40, then this has to be 140, right? They add up to 180. There's no straight line there, is there? Because if you keep going, you hit that line, it doesn't keep going. So straight lines, you should be able to identify them and use it to your advantage, right? Like down here, this example, the orange is your straight line, and you have 3 angles, one of which is unknown. You take 180 degrees, take away the 2 that you know, and then voila, you get your last one there. So that is important. That was review. Another important one, and I want you to have the shortcut. Like, this is very short. This is on page 3. Vertically opposite angles are congruent. What is congruent, Mr. Dirksen? Looks like an equal sign with a third wave on top. Yes. Congruent is a fancy term for equal. It's the same thing. We're saying that the angles are congruent. When there are numbers attached to it, you can say they're equal. Okay? So essentially, if you see 2 lines or more crossing, right, then the angles that are created that are exactly opposite each other are always going to be the same. Okay? So that's something to remember. At the same time, folks, do we have straight lines? Yes, there's one right there. So these 2 should add up to what? 180. You have a straight line there, correct? These 2 should add up to 180. Yeah, it's tough to answer first thing in the morning. I get it. And so I did do an example here. I kind of highlighted the vertically opposite. If you're ever unsure, just trace that line, trace the other line. It's right. The 2 lines that create the angle, you trace them over to the other side. There it is again, right? So those angles have the same 2 sides shared, okay? That's how you know that you did that right. There's sum of a triangle, right, is always equal to 180. The angles inside a triangle, always 180. You knew that, right? Please tell me yes. Yeah. I wasn't sleeping in grade 7, 8, 9, right? Okay. Sum of any 4-sided shape is always 360. And I need you to know it doesn't matter what it looks like. Okay? Any time you have 4 sides, the sum of interior angles is 360. The easiest one is a rectangle because it's 90, 90, 90, 90, right? 4 times 90 is 360. but it is true for any four-sided shape. That's going to come in very handy down the road, trust me, okay? We don't want to forget about it. Last but not least is three-letter angle notation. This one I need you to be comfortable with, okay? So I'm trying to see what I did here. Angle Z. Yeah, so I inserted some letters here. Again, your notes might be a little different, so if they're different, just leave it for now, just pay attention. But if I wanted to refer to this angle up there, this one, I can't just use the letter B, it doesn't work. Because B has this angle and this angle in it, right? So you can't use B alone, you have to use other letters. So if you want to refer to this one right here, you just start here, let's say, and you go A to B to D. So ABD, right, is one way to refer to that angle. Or you can start here, D to B to A. So basically, if you connect those three letters, you should see that angle that is formed by connecting those three capital letters. I am a big fan of, when you're doing your worksheets, to, as soon as you find it, give it a letter or a number. So number 1, number 2, but don't keep it like that, because I don't know, I can't do it, guys. I'm a math teacher, I should be able to. ADB, yeah, it's easy to find. ADB, right? I know it's here, because it's ADB. I'm going to give it X, so I go on my sheet and I call this angle X. So now I don't have to worry about the notation. I'm like, this is the one this thing is referring to. Okay, so that's something to remember. This last one here, I think I just made this up as I went, but if I asked you what's the measurement of angle, this is angle symbol, BAE. So you go B to A to E, right? So that's what you connect, and it's this angle, right? If you think of B to A and A to E, you got to connect the two sides that you traveled on, right? That's the angle we're talking about. In this case, it's 83 degrees. Angle, this is angle, so don't mistake it with a triangle. Sometimes there's a triangle there, right? But this is angle, LFD. Where's LFD at? LFD. You traveled on these two sides, so you must connect them to identify the angle. We're talking about angle, the angle that measures 103 degrees, and so forth, okay? And we identified vertically opposite. There's vertically opposite here. There's vertically opposite angles everywhere, to be honest, okay? So that's another review. And if you don't know what I'm talking about, I don't think I asked too much in terms of homework. But I know some of you are studying for other subjects. I know that. I know that you're studying for other subjects. I heard bio, right? Is there a bio test after this? Yeah. Guess what? It's going to happen from time to time where you're going to have to decide what to pick. Like, I need to study for this right now. I'm right now a student myself. I don't know if I told you, I'm in university right now doing my master's. I've got tons of reading to do, but I also have to mark my tests. So I finished almost all of the tests, and then I had to do my reading yet. Because otherwise, if I don't do it, it just piles up, right? And you're behind even further. So, and you're like, oh, that's easy because you're a teacher, you know your stuff, and university is probably easy for you. No, it's not. It's not easy. It is a balancing act, right? So you got to learn that. I know that some of you fill this in, and I really appreciate, I can see, right, when I walk around. I'll walk around later and just check a little bit. So I'll either give you the stare of, you know, you should be doing your homework, or the way to go, you did it, right? This one right here, everybody go to this example right here. So if I were to ask you, after everything we've reviewed, to determine all of the missing angles, and I was nice, I didn't use three-letter angle notation, you should be able to do this. And if you're just here and watching this and you're like, I've got this, I did the lesson, way to go, okay? Z, so it doesn't matter where you start. Maybe I'll start with, I want you to tell me at least where you start your journey, and then I'll follow your path, okay? How could I solve for angle X, this angle right here? Those of you who did it, this is a freebie. You can tell me, what should I do there? The entire triangle. So Chandra saw a triangle, and you saw that this is 60 and that's 70, right? So yeah, zoom out, zoom in, zoom out, zoom in, right? Like that's how these ones work. So angle X, this is 60 and 70, that's 130, right? So this must be 50. So what I do is I use 180, I subtract 60 and 70, and I'm left with 50 degrees. And I tell myself to justify, so I do some work, and my reasoning will be that the sum of a triangle, those angles add up to 180. I used to make students write out a nice sentence, and it just got too messy, and I have to do more reading. And that's not the point. The point is, do you understand the property that you've used? That's why I've introduced the shortcuts, okay? What do you want to do next? There's lots of options, by the way. I am going to, the one that's easiest for me is, I see that this 85 is vertically opposite to this one right here, right? They share the same two sides. So Z is 85. That's my second choice here. The second entry that I'm going to do. Zero math, just property. So I will say this, vertically opposite angles are equal to each other. Boom, you got that. And if it helps you, some students like to actually fill in the measurements. Okay, there we go. Y. Or which one do you want to do next? I forget, Joel, which one should I do next? Just tell me which one to do next. Why? Why not? Okay. So why? What property can I use? Supplementary, yeah. So there, Joel probably did his homework, but that, right, there's a straight line there, and they're supplementary, okay? So we're going to go 180. Watch this. It's just 180 minus one angle, because right now I'm not using a triangle. I'm just using a straight angle, right? So this would be 95 degrees. And this is my justification. Straight angle is equal to 180, or you can say supplementary angles. Supplementary angles, because they're along the straight line here. These must add up to 180 degrees. So there we go. Got it? And obviously the next one is M. Let's see here. Is there anything else I can use? No. I have to use supplementary as well there. So M is 180 minus 45, which is 135 degrees. Straight angle is equal to 180. So this is 135. So I'll usually give you half a mark for the number, half a mark for justification. So if you get the number wrong, but the justification is correct, you can still score marks out of that one. I'm going to go ahead and write this down here, 135. If this is 135, what is this one here? What are these? Vertically opposite, right? 135. Is there a way to find y using a different property than what we've used already? Paulina, what is it? Right, we have a four-sided shape, right? So what should all four add up to, technically? 360, right? So I can go 360. Does it even work? Because sometimes I don't check to make sure that it should work, in theory. Let's see here. So y, we're claiming it's 95 degrees. We use straight angles, but if we were to go 360 minus 135 minus 70 minus 60 I hope it works. Yes, it works. 95 degrees. So I hope you're starting to see the picture that it all should jive. Question. You're awake, right? What should these three add up to? It's a triangle, correct? It should add up to 180. If it doesn't, we're in trouble. So let's do some mental math. 85 and 45 is 130, plus 50 is 180. That works out. Okay, so as you get through this, everything that I've reviewed, it's now in your pockets and you can use it as a tool, right? Oh, I'm going to use this tool for this one. I'm going to use a different tool for that one. So when you check the homework or when I do the key, you might say, wait a minute, why did he do it that way? I did it differently. Totally fine, as long as it jives, right? It has to jive. If it doesn't work out, your numbers are different, then we have a problem. But technically, you should all arrive to the same conclusions. All right. Fun stuff, eh? Yeah. We're doing trig after this, trigonometry, and it's not SOHCAHTOA. I don't know if the SOHCAHTOA ring a bell. Sine, cosine, tan. We're doing different trig. So if you were asleep in grade 10, you get to redeem yourselves with this trig. It's a different way to solve. We can solve for any triangle. It doesn't have to be a right triangle. It can be any type of triangle. We'll solve those, okay? So this is kind of getting us ready for that unit. Next, parallel lines. This is important. You need to know that one. What's the tragedy about parallel lines, guys? The tragedy is they have so much in common, but they'll never meet. That's the joke for today. They have so much in common, right? They have the same angles, everything, but they will never meet. Okay, they never meet or intersect. Parallel lines, you can have a symbol, like this symbol here, like this line and this line will never meet. They are parallel to each other, which is huge. Okay, that is going to be huge to us. They're basically copies of each other, guys. They're copies of each other. And this one is a copy of that one. So you've got parallel lines. I don't know if I did this in the notes, but technically if a question doesn't have the symbols in it, you can say stretch AB, so this stretch, is parallel to this stretch right here, CD. Also, what do we know? EF is parallel, EF here is parallel to GH. All right. If it's not parallel, you cross out that parallel line, symbol if lines are not parallel. Okay? What shape is inside there? Like right in the center, what do we call that? What were you saying? No, I'm not going to get. Do you remember a parallelogram? Parallelogram, I don't know what grade you would have. But if you have something that looks like a slanted rectangle, and you know that this line is parallel to that one, this is a parallelogram. Okay? Instead of a candygram on Valentine's Day, you can send someone a parallelogram instead. Okay? Anyways. A transversal. Transversal is the line. If you have multiple lines and you zoom into just one of them, right, it crosses across maybe two or more other lines. Okay? So this is what we call a transversal. We put a T there, or transversal. I want you to think of a transversal as that's the line that we're going to travel along. Okay? We travel on this one. When a line is referred to as a transversal, okay, highlight this, there are four distinct pairs of angles. This is where it gets new. Unless you kept watching, you couldn't resist my video, and you said, you know what, I'm going to stick around for the whole video and keep going. I don't think that happened, right? But that's a transversal right there. However, I want you to have one more example, and this is new. Sometimes students kind of mix up. So just draw something like this. If you travel along this one, we would call this transversal 1 because it crosses 2 or more other lines. You could call this a transversal 2. Transversal, it crosses 2 or more lines. Okay, that's when you travel on that one. Let's say you were to travel on this one. It crosses 2 or more lines. So technically, in this scenario, there are 4 transversals. You just have to pick which one are we going to travel on. Okay. All right. That's fun, eh? Yes, I know. Okay, now this is the new part. This is the very important part. This is something that we're going to use a lot. So go to page 5. And if you can have a few highlighters, it's going to help you a great deal. Four distinct angle pairs found along the transversal. And I'm just going to focus on, I won't necessarily highlight them all, but I just want you to be aware of them. So if you talk about corresponding angles, okay, let's say right now this is our transversal. I'm going to put a T there. Transversal. If you travel along that transversal, these 2 lines, think of them as like the bread of your sandwich, okay? Anything that's inside and between the lines, like all of this area, is called interior. And therefore, anything outside that's not in between those 2 lines is what we refer to as exterior. So that's something you need to be very aware of, that we have interior, we have exterior. All right, so corresponding angles, I'm just going to highlight one of them. A corresponding angle would be, if you focus in on the one that would correspond to that one would be 5. Okay, 1 and 5 are corresponding angles. So there are 4 pairs. I will say this, just to help you out. Same side of transversal. They're on the same side of the transversal. They're non-adjacent. Non-adjacent is a fancy term for they don't touch. They don't touch. That's what non-adjacent is. So it can't be. So same side of the transversal. They're non-adjacent. One is exterior. One is interior. This is the definition of it. I don't necessarily need you to memorize this. I just need you to be able to identify them on a diagram. So there are, how many pairs do you have? 1 and 5, right? Then you have 2 and 6, 4 and 8, 3 and 7. Yes. Okay, so there's 4 pairs here. I'm going to list them. Angle 1 and angle 5, angle 2 and angle 6, angle 4 and angle 8. angle 3, and angle 7. So I'm gonna highlight 1 and 5 here. Just so you see it. Oh, that's the one. That's the pattern. Okay? All right. Next, we go to alternate interior angles. Alternate interior. What does alternate mean for us? Think of crisscrossing. Okay? That's what I want you to think of, alternate. And what does the word interior tell us? It means that we're going to find them in the interior, on the inside. And angles, you all know what angles mean. Okay, so here's the definition. Opposite sides of transversals. Transversal. They are non-adjacent. What does that mean? They don't touch. They're not right next to each other. And that's it. That's it. I don't know why I put a third bullet there. So I'm going to highlight one of them. I'm going to use a different color just so if you're in the interior here, this would be one of them. And then you go across the transversal because they can't touch, right? They can't touch, so it's a cross like that. In this case, you've got two pairs. Angle 4 and angle 6. And which other ones? 3 and 5. I don't know. I'm going to do this. You choose. But we're focusing on the interior. Exterior, in this case, do not come into play. Everything is interior. The name says it all. Interior. Okay, we're focusing on inside. So that they're called alternate exterior. And if you're wondering why are we talking about this, because we will find out something about them down the road. Let's keep going. There's two more that I need you to remember. Alternate, I want you to think of, they're going to be crisscross. And exterior, I think you all know they're going to be outside of the sandwich bread, right? Outside of the burger buns. I don't know, whatever you want to say. And angles, we all know what that means. So, different color. If I said, I'm going to first define them and then I'll ask you. They are on the opposite sides of transversal. I'm just going to use T. Okay, this is my T right now. And they are exterior. Both of them. Now I know what I wanted to do on the previous one. I'll do that in a bit. We'll finish this. So opposite sides. What gives away opposite? It's the word alternate. So if I were to say 2, and you have to go, they both have to be exterior, then that 2 would go with the 8. So crisscross like that. And the 1 would be alternate exterior to the 7. So you're basically just focusing on exterior. I'm going to go exterior, exterior. So there's 2 pairs in this case. Angle 2 and angle 8, as well as angle 1 and angle 7. Yes. One thing that I'm going to tell you, this one right now, we're traveling always up and down. But this whole thing could be like this sometimes. You're messing up my notes, Mr. Dirksen? I like that. But we still, if we travel along this transversal, this is still the interior. And so these would be alternate exterior, 1 and 7, 2 and 8. 3 and 5, 4 and 6 are alternate interior. And then we've got our corresponding where 1 and 5, 2 and 6, 4 and 8, 3 and 7. Okay, so it doesn't matter which way, you kind of want to travel along that transversal. And last but not least, I call them the CIAs, okay? In short, consecutive interior angles. Consecutive, it means they're adjacent, they're right next to each other. And interior, of course, they're going to be both on the inside. Okay, so here we go. They are both inside. They are, they are actually non-adjacent, sorry. Same side of transversal. They're on the same side of the transversal. I'm running out of colors. So one pair would be 3 and 6. Okay? So I'll say angles 3 and angle 6, as well as 4 and 5. Those are called consecutive interior, CIAs. And then I need to make sure I add one thing to your notes there, alternate interior. I didn't say that they're both on the inside. They're both interior. So I'm going to go up here. Here I'm just going to add a bullet. Both interior. And the name kind of gives that away, right? So we've got corresponding, alternate interior, alternate exterior, consecutive interior. So these four, if you can, have it somewhere on your study sheets because it's going to help you out. All right. Angles formed by parallel lines. So this is where these four take a bit of a twist. We're now talking parallel lines. Highlight this part. When a transversal intersects lines that are parallel, then all of the following properties are true. Okay. I will rephrase, but basically alternate exterior angles are going to be the same. Alternate interior angles are going to be congruent. If you want to put down congruent, that symbol. Corresponding angles are congruent. And what do we know about consecutive interior angles? They are supplementary. That means that they add up to 180. Okay? So these four things are always going to be the case if you have parallel lines in the mix. Okay? Let's use that to help us out here. What's that blank space for? Later. Okay? I will leave it blank for now. Let's see, I used a software called GeoGebra. Has anybody ever heard or used GeoGebra? Anyways. What's up, brah? Right? Anyways. Let's look at, I want you to cross like, this is a transversal, this is a transversal, There are many transversals here. But we're going to cover this up. And we're going to call this T1. We're going to focus in on that transversal and do a bit of investigating. What would we call this angle right here and this angle right here? What's the name that we have for that pair? If you could go back to page 5, what name would we give it? Corresponding. Do you notice that they're exactly the same? That's interesting. Okay. Let's do our next one. I think I used orange for alternate interior. What would this angle be and this one right here? They're both inside, right? They're alternate interior, okay? And they're the same, correct? All right. What would we call this one and this one? If you had to use your page previously. Alternate exterior. And they're the same, correct? Yeah. What do we call these two here? These are consecutive interior. They're CIAs. What do they add up to? Can we do some mental math? The 2 and 118 is 120, plus 60 is 180. So the CIAs are equal to 180. Interesting. So the corresponding alternate exterior, alternate interior are all the same, and the consecutive interior angles add up to 180 degrees. The conclusion here is, guys, watch this. You ready for this? That because we traveled along the transversal and we observed this, we can now say that this line is parallel to that line. We can confidently say that. Think about it. Look at all these angles here. Don't you see the exact same angles over here? This intersection is a copy of this intersection there. So what that means is whatever is happening here in terms of angles is the exact same thing that happens up here. And that leads us to believe that these lines are never going to meet because they're copies. They're pointed in the exact same direction and just keep going indefinitely. Okay? So that's what makes lines parallel when you observe the same thing happening in both intersections. Let's focus in on transversal number 2 here. Do you observe the same things? We're not going to highlight here. But what are these two called here? Alternate exterior. 80 and 80 is also alternate exterior, okay? The alternate interior angles are also exactly the same. And this adds up to, I made it easy for you, 180. So no matter where you slice this, guys, it doesn't matter where you slice it, you should observe the same things once you've determined that these lines are parallel, okay? All that just to make a short little point, right? I know, I overdo it sometimes. All right, I want you to, we're going to skip 7. I want you to go to page 9. I'm going to give you some class time to work here. And I know some of you are just going to put down numbers, but that's not what it's about today. Today it's about using the right properties, the 4 specifically that I talked about. So watch this. Go to page 9. I know they're a bit blurry. I apologize. My scanning tool was not the best. But this is what I want you to focus on. If we know that these lines are parallel, then this is what we call the transversal. Right now, we travel on that one. It turns out that one of these lines could also be a transversal if there had been another line, right? If it crosses more than one. But right now, we're going to take it nice and easy. Question mark. We're going to call the question marks X, okay? We're going to call all of them X. What is angle X going to be equal to? 116, right? But why? What do we call these two? Alternate exterior. And you would just alternate exterior angles. We know that they're the same. Bless you. Okay, so you go comma, explain. So number, and why did you make that call? Okay. What about this one here? Angle X is what? Because we know the lines are parallel, right? That's pretty sweet if we know the lines are parallel. Then the four things we just talked about are true. So this is going to be 100, correct? 100 degrees. Don't forget your symbol. But why? Alternate interior angles. If after today you're like rolling your eyes every time, it's like, I know that one, Mr. Dirksen, I know it. I have done my job. That's what I want after today is like, I know where it is. I know what we're talking about. Okay. I'm going to skip a few because you're going to have to do some yourselves. I want you to go to 6. This is X. What's angle X? I know. 79. I was hoping you were going to say 101, then I could say you're wrong, but you are right. It's 79. Because these are supposed to add up to 180. So I'm going to go 180 minus 101. That's 79 degrees. Okay? So yes, this is where you break the pattern. Things are not the same here. But you will say that consecutive, don't do CIAs just yet. You can do that later. Okay? Consecutive interior angles are equal to 180 degrees. That's what I allow you to use there. Mr. Dirksen, what if I said consecutive interior angles are supplementary? Fine. Absolutely. What if I say CIAs are equal to 180? Fine. But just make sure you use one of the properties we have talked about. Okay? I'll leave you alone for now. I will introduce more lines, but maybe I'll just warn you once you get there. So I'm going to skip, for example, let's say we go to a scary one like 14. Let's go to 14 real quick. There's lots of lines, correct? Where is the number? The number is touching this transversal here. And now I want you to do a mental exercise where you ignore this one, for example. You ignore that line. What do we call these two here? Like this. This is my sandwich. This is the buns of the burger right now that I'm eating. This one is inside. This one is outside. They're called corresponding. These are corresponding. Okay? This is the pattern. They're both on the same side of the transversal. One is inside, one is outside. So if you call this X, I'm just going to do this one with you. That's 73 degrees because we know when they're corresponding, they're the same. And you just say corresponding angles are congruent. Okay? So I'm going to leave, so I want you to do all the way, everything up to 12. So from page 9 all the way to 12, see if you can wrap your head around it. But wait, there's more. If you're already willing to go to 13, I'm starting to introduce variables. Like, why would you do that, Mr. Dirksen? I'm trying to forget X, right? My X. And you're like, here's another X, right? Anyways, I'm just kidding. You start that one. But go with 9. Start with 9 and fill all that in. I want to see, in particular, the justifications, okay? I still want you to do all the pages I've assigned, but we'll just take some here on page 10, for instance. This is X, If you see that they're parallel, a lot of students think it's always going to be the case that they're the same. Only if lines are parallel, and in this case they are all parallel, so you don't have to worry about that. Angle X is equal to 98 degrees. This is page 10, question 9, because alternate interior angles are supposed to be the same when lines are parallel. Over here, we know that this is supposed to add up to 180, right? So angle X in this case would be 180 minus 60, that's 120 degrees, because consecutive interior angles are equal to 180 degrees. Okay? This question puts a little bit of a twist to it. Pay attention. Find the measure so that the indicated angle so that U and V are indeed parallel. So what do we need for lines to be parallel? Well, we need corresponding angles to be congruent. We need alternate interior angles to be congruent. We need alternate exterior angles to be congruent. We need CIAs to add up to 180. Okay? That's what you need to make two lines parallel. Listen carefully to this part. If you make sure that one of these is true, it turns out that all of them are true. That's what a property that we're going to discuss further tomorrow. So what would make most sense right now? It would right now, based on where they're located, it would make more sense to make sure this angle is is supplementary to that one. So I will say this, angle X would have to be 180 minus 63. Okay, so that's 117. Because CIAs are equal to 180. And then note, it turns out that all of these are true. Okay? All of those are true. If you make sure one of them is true, it turns out that all of the other ones are also going to be correct. Okay? Let's do a little bit of investigating. If this is 117, what's this angle here? Like this is a straight line here, right? This is going to be 63. Oh, wait a minute. Alternate interior angles are congruent. Okay? So it kind of confirms one thing that we've just talked about. Before we go, I need you to know this one. And I will see you tomorrow already on things that you see here. Sorry, I'm going to skip. So all the way up to 12 is U. Then go to 13 here. Page 13. Determining the value of X. So this is a little different. Go to page 13. Make sure you write this down. It wants the value of X, but what does this angle have in common with this? What does this box mean? 90. Yes, thank you. What do we know about those two? What are they called? Alternate exterior. All right. So what do we know about alternate exterior? They will be exactly the same, correct? All right. So you set it up like this. Watch. It's a lot of fun. 21x plus 6 is equal to, this angle right here is equal to 90 degrees. Oh, so now it's an equation, and it's x. Solve for x. What do? We subtract. So x is the variable you want to isolate. First, get rid of something that's adding or subtracting to that expression. So I'm going to go minus 6, minus 6. You do the same thing to both sides. I don't know if you remember that. then you're actually not affecting the calculations. And now what do? The 21 is multiplying x, so we will divide. Please don't subtract, right? Now you're dividing. And x is equal to, mental math, how many times does the 21 go into there? It's actually 4 degrees, right? Boom, you're done. If you plug in x into this, 21 times 4 is 84, plus 6 is 90, right? So we can check. 21 times 4 plus 6 is 84 plus 6, which is 90 degrees. And that's exactly what you would expect in this case. I'll do one more. I thought you said one more. I know. I lied. Teachers are just a bunch of liars. Because they'll tell you can't take the root of a negative number. Have you heard that lie? You can actually take the root of a negative number, square root, but that's down the road. What are these two called? CIAs, all right. CIAs. What do we know about CIAs? They add up to 180. So, question, they're not equal to each other, right? This one is not equal to that one. They add up to 180. So, watch what I'm going to do. I'm going to take that first angle right there, and I'm going to add the second angle right there. I don't like where this is going. You'll be fine. And what should I end this equation with? Equals 180. Janmar, I could read your lips, so thanks. And because it's a plus there, you can actually get rid of the brackets. It's just like this. If there was a negative here, you'd want to distribute. In this case, it's just that. And so we combine like terms here. X and x, 2x, 96 plus 96 is 192. And that equals to 180. Don't forget about the equals to 180. And now it's basically what we did before. Most of these are fairly straightforward. And so you subtract, you get, right, this cancels out. You get that 2x, that's all you're left with on the left side. 180 minus 192 is negative 12 degrees. Then you divide both sides by 2. Wait a minute, is this going to be a negative? Yep. Negative 12 divided by 2 is negative 6 degrees. And there you have it. Let's plug that in. Like, what do you think this is going to be? If you plug it into this one, what's negative 6 plus 96? 90, right? And you'll get the same answer here. So 90 degrees and 90 degrees would give us the 180. So it's kind of, I would like you to either mentally check real quick. I don't expect you to check, but yeah. So when they're consecutive interior, guys, you're going to have to add them up, make them equal to 180, and then solve. All the other ones are just going to be equal to each other. You don't have to do the plus, right? Okay, so I will say this, 9 to 14. If you do every other question, I will be happy. You don't have to do every single one. I would prefer you doing every single one, but apparently some of you are studying for bio, right? Or whatever else, chemistry. Do every other one at least, so you're prepared, okay? Thank you, guys.